guys, hi everyone, welcome to Easy B Tech. Myself Srikanth Ganji. So here I want to teach DC generators, that is unit 1, that is there in JNTH curriculum electrical machines 1 subject. So in this DC generators we have a principle of operation, action of commutator, and constructional features. All these one we'll discuss one by one. So what are the fundamentals are required? So what are the fundamentals are required for DC machines and DC generators? So first one is Faraday's law. Faraday's law. So that to first law, what is meant by Faraday's first law? Whenever flux linking with the coil changes, flux linking with the coil changes, an EMF is induced. Coil changes and EMF electromotive force is induced in a coil or conductor. Coil or conductors. So the magnitude generally we will design the Faraday's first law only. So what are the basic requirements for production of EMF? What are the basic requirements for production of EMF? So first property, first need magnetic field, and second is set of conductors, and third is the most important point, there is a relative motion. There is a relative motion between 1 and 2, then only the EMF is induced, otherwise the EMF is not induced. Generally the magnetic field is produced, the magnetic field is produced with the help of a permanent magnets. P dot M means permanent magnets, and E dot M means electromagnets. So we know that dia, para, and ferromagnetic material or belongs to permanent magnet, and electromagnet means, so I will take an iron piece, soft iron piece, that may be silicon steel, soft iron piece, and some coil is wounded on this, some coil is wounded like this, and this is the sense of winding. If the current is passes through this coil and the current flows like this, if the rapid finger represents the direction of the current, thumb indicates the direction of the flux according to right hand grip rule. So this is the flux lines are developed around the electromagnet, and always we know that the flux lines are flowing from north pole to south pole externally, but internally it is south pole to north pole. By giving an electrical supply which is acts as a magnet, then it is called as a electromagnet. So the second property is conductors. Yes, the conductors are made up of copper. The conductors are made up of copper or aluminum. We know that copper is the best conductor. And if there is a relative motion is present, then the EMF is induced. Now coming to our electrical machines 1. So what is our question as per J into H? Explain the principle of operation of DC generator. DC generator. So first of all, I am taking an electromagnet. So some coil is wounded on this piece, soft iron piece, and I am excited with the DC supply. I'm excited with DC supply, and the current passes through this coil like this. Then it acts as a north pole, then it acts as a south pole. Anyway, it is a enclosed one like this. See, so this is a magnet which looks like a horseshoe. That's why, because it is not a open. So not, we are not getting single north pole and single south pole. So it is a enclosed one. This is the construction. Now I am taking a single conductor. Single conductor. The front view of the conductor is dot, and that is rotating in anti-clockwise direction. So, okay, I am rotating the conductor with anti-clockwise direction. The tangential force which is acting on the conductor is like this, and here it is downwards. At this position it is like this, and here it is upwards. This is the fourth position. When the field winding, this winding is called the field winding. Why it is called as a field winding means the winding which will produces the magnetic field is called the field winding. You can remember like that. Okay, the flux lines are flowing from north pole to south pole. See, at the first position, the tangential force acting on the conductor or the motion of the conductor, it is in this direction, and the magnetic flux is in the opposite direction. There is no cutting action, so no flux lines are cut. No flux lines are cut by the conductor. Cut by the conductor. Induced EMF is 0. At second position, if you observe at the second position, the tangential force is downwards, and the magnetic flux lines are exactly perpendicular. See, 90 degrees. That means maximum number of flux lines are cut by the conductor. Maximum number of flux lines cut by the conductor. And coming to third position, if you observe the third position here, the tangential force acting on the conductor, it is like this from north pole to south pole like that. And here the magnetic flux lines is in this direction. Flux lines, this is a force, tangential force. This is a force and flux lines. And there is no cutting action, and induced EMF is 0. And coming to the fourth position, so the tangential force will be like this, exactly perpendicular but is in opposite direction. The flux lines are in this direction. The maximum number of flux lines are cut by the conductor, and induced EMF is maximum. Induced EMF is maximum. In order to complete one revolution, so again it will comes to one position, the induced EMF is 0. So if you draw the waveform, if you draw the waveform, this is at 0 position, sorry, 1 position, 2 position, 3 position, and 4 position, again it is 1. At 1 position, the induced EMF is 0. At 2 position, the induced EMF is maximum. See, at third position, induced EMF is 0. At fourth position, induced EMF is negative maximum. Why? Because I am taking the negative maximum means previously it will be tangential force will be downward direction. Now it will be upward direction. Anyway, the direction of the induced EMF can be decided by the Fleming's right hand rule. So again, it is 1. So if you join all these points, then the sinusoidal waveform will be generated. The sinusoidal waveform is generated. Sir, you are talking about DC machines, but the EMF which is generated is AC. How we can convert AC into DC? We have a one rectifier, which is called the rotating rectifier. It's called commutator. With the help of a commutator, we can convert negative of cycle into positive of cycle. So that is called the mechanical rotating rectifier. We'll discuss one by one. And this is the principle of operation of DC generator. So whenever flux linking with the coil changes, an EMF is induced. E is equal to BLV sine theta, where B is called the magnetic flux density. And L is the active length of the conductor. And V is the velocity of the conductor. And theta is the angle between, suppose this is a conductor, right? Yes or no? Theta is the angle between the magnetic field and the position of the conductor. So magnitude of the induced EMF is decided by the magnitude of induced EMF is decided by Faraday's law. And direction of the induced EMF is decided by Fleming's right hand rule. Stretch the three fingers. One is perpendicular to another. If thumb indicates the motion of the conductor, forefinger represents the direction of the magnetic field, and middle finger represents the direction of the induced EMF. Thumb indicates the motion of the conductor, and forefinger represents the direction of magnetic field, and middle finger represents direction of the induced EMF. Let's check for this above diagram. See, at second position, the tangential force acting on the conductor is downwards, and the flux lines are coming from north pole to south pole like this. It's a north pole to south pole, and the current is coming outwards. The current is coming outwards. So here it is, the current is represented with the dot. Under the north pole, you can observe that the tangential force is upward. The flux lines are coming from north pole to south pole, and it is into the conductor. It is into the conductor. So here it is cross, and here it will be dot. So if I am taking the, in sometimes in examination, simple loop generator is also he will ask. Simple loop generator. Explain the principle of operation of DC machine or DC generator with simple loop. I am taking a two conductors. One is a conductor AB and another conductor is CD. The ends of these two conductors, so AB is one conductor, CD is another conductor. The ends of these two conductors is joined like this. Okay, then it is called as a single turn, right? Okay, this will be rotating with the help of a prime mover. What is meant by prime mover means an external device which is used to rotate the conductors is called the prime mover. So north pole and south pole will be like this. Yes, this is the position of the poles. This acts as a north pole and south pole. Anyway, we have a winding like this. Yes, winding. Okay, and what is meant by active length means up to this portion only. Up to this portion only, the conductors are experienced by the flux. You can observe here. Here also same thing, right? So up to this only, these are present in the magnetic field. This length is called the active length of the conductor. So I will take one textbook here. Suppose this is the conductor A and B, and this end can treat as C and D. Once again, so this starting end is A, and here it is B. Top is B, and top two is C, and bottom is D. What is the front view of this one is? The front view of this one is just like a small rectangular, right? Sun. So now this is the front view, right? A sun. Let us say this is called the conductor AB. So B and C is looking like this. Let us say 1 comma 2, and this one is 3 comma 4. So after quarter half rotation, this is 1 comma 2, and this one is 3 comma 4. So after quarter half rotation, this will be rotating in an anti-clockwise direction. So after half rotation, what will happen? So this 3 4 is comes at this position, and 1 2 comes to this position, and again you can go for the quarter half, and this will be 3 comma 4, and the upside is 1 comma 2. So this one is 1 comma 2. So in order to complete one revolution, so in order to complete one revolution, so this is at 1 comma 2, and this one is 3 comma 4. And if you observe from the bottom, so if you observe from the bottom, so actually the position of the conductor is like this. Sorry, no, the position of the coil is like this. This is a conductor AB and this is a conductor CD. Sorry, conductor AB. See here, conductor AB and conductor CD are, you can say that it's a 1 comma 2 and 3 comma 4. So this one is 1 comma 2 and this is 3 comma 4. So what is the front view of this one? Tell me. 1 and 2 will be coincidence and 3 comma 4 will be coincidence, like this. Okay, so at 1 comma 2 what will happen? So the tangential force will be, one is anti-parallel and at this position is parallel, then the induced EMF is 0. This is the first condition. And the second position, you can observe at the second position the maximum number of flux lines are cut by the conductor. Yes, this is the number of flux lines are in this direction horizontally. You will take horizontally, this is the number of flux lines are coming like this. The number of flux lines are coming like this. You will take it. Okay, what is the meaning of this one? So here I have a poles like this, north pole and south pole. So the coil position is like this. So this is 1 comma 2 and 3 comma 4, and after this will be rotating in a anti-clockwise direction. So number of flux lines are cut by the conductor is maximum. And at this position, yes, the tangential force acting on the conductors 3 comma 4, yes, sorry, conductor 3 comma 4 and positions is anti-parallel and this one is parallel. Again it is 0. At this position is maximum. At this position is 0, original position. So again it will generate the sinusoidal waveform. It will be generate the sinusoidal waveform. So E is equal to BLV sine theta. E is equal to BLV sine theta, and BLV can be written as E max, where theta is represented as omega t, where omega is called the angular frequency. Okay, it will be rotating in omega, that is called the angular velocity, and so this is the angular frequency, and t is the time. Okay, and linear velocity is v is the linear velocity, E max sine omega t. So that is our generated EMF equation. This equation is used in single phase AC circuits, that is there in BW subject. So with these two questions are covered, and one question is explain the principle of operation, means general expressions you can go. So with this explanation, at first position, second position, third position, fourth position, you will take it, the conductors are rotating in a anti-clockwise direction. The conductors are rotating in a anti-clockwise direction. At different positions, what will happen? And the second method is explain the principle of operation of simple loop generator. Okay, so with singleton alternator also. Singleton alternator. I am taking the conductor 1. See, this is a one conductor, this is another conductor. Conductor starting position is 1 and finishing terminals is 2. And conductor 2 is, let's say this is starting is 3, 4. And these two are joined by wire, external wire. So this is called the end connection. And the conductors which is existing under the presence of magnetic field, then it is called as a active length of the conductor. Okay students, we'll see in the next video. So what is the construction of a DC machine? So thank you.